Welcome to Petrochemical Diary. Today I'll be treating the classification of a separator by orientation, phases, and pressure. So by orientation, we have vertical separator, and we have horizontal separator, and also we have spherical separator. But in oil and gas industry, spherical separator is not always used. So also we have by phases, we have two-phase separator, and we have three-phase separator. So classification of separator by pressure, we have low pressure separator, we have medium pressure separator, we have high pressure separator. So today we'll be consider when to use vertical separator, when to use horizontal separator. So when you see a vertical separator in any industry, the question you ask, why do we use vertical separator in this place? Why don't we use horizontal separator? Why do we use vertical separator? And when you see a horizontal separator, you say, why do we use horizontal separator in this session? So after this video, this question will be clear for you. So after the video, when you see a vertical separator, you will know that yes, we have to use vertical separator here. Yes, we have to use horizontal separator here. The purpose of vertical separator and the purpose of horizontal separator, their function. So let's come into it. Today I will be treating the classification of vertical and the classification of separator by orientation, that is the vertical separator and the horizontal separator, and when we have to use vertical separator and when we have to use horizontal separator. So let's come into it. Like I said the classification today will be treating the classification of oil and gas separator by orientation, which is the vertical separator, the horizontal separator, and the spherical separator. So we can see the vertical separator here. We'll come to all this. So we see the horizontal, the spherical separator. Like I said, the spherical separator is not always used in oil and gas industry. So we always use, when you go to oil and gas industry, you always see vertical and horizontal separator. So we explain this vertical and horizontal separator and when to use them, which session to use them. Like when you get to oil and gas industry, you will know why do we use a vertical separator here and why do we use a horizontal separator here. So first of all, let's come to vertical separator. So vertical separator. So when do we use vertical separator? So vertical separator is used. Vertical separator are the most considered for gas purpose, and as you can see here in the vertical separator, you can see here we can see the gas space here, the gas at, and you can see the water oil. That means the gas will be at the top, of course, as we know, and the oil and the water will be at the bottom. So we said the vertical separator are much considered for gas purpose. So we only use vertical separator when we want to separate gas. That means you can say when gas are mush in a crude oil. When we have much gas in our crude oil, we use vertical separator to separate the crude oil, to separate it. So it helps us to release that gas because it's a vertical. No, we starting is a vertical. Let me draw the vertical separator here. So you see, for example, this is a vertical separator. Example, this is a vertical separator, and our gas outlet is here. Also, we have our liquid outlet here. So you can see here that the reason why we use vertical separator is because when crude oil have much gas and you want to separate the gas, it's better to use vertical separator because the gas will easily release via the gas outlet here. Sorry for my writing. Not the gas outlet. So it's better for you to just understand it that if we are to use vertical separator, means that we have much gas on our crude oil, and we want to separate the gas for the crude oil. So gas easily release from our vertical separator than the horizontal separator. So I hope you understand that. Another thing we have to note that is our vapor. So it's better for you to understand it. Don't look at the writing. So the best thing is to understand it. The one thing we have to know is that our vapor fraction. So if our vapor fraction is equals to 0.9, that's our 90 degree, 0.9, we use vertical separator. So that means if we have much gas on our crude oil, we use vertical separator. That is the 90% of gas we use vertical separator. But if it's about 0.7, this is about 0.7 or 0.8, we use horizontal separator. So if it's about 0.7 or 0.8, that means 70 or 80% we use horizontal separator. That means the gas, the amount of gas on the crude oil is low. So we use horizontal separator for that. So you understand it that when we have much crude oil on our when we have much gas on our crude oil, for us to separate it, we use vertical separator. It helps the gas to be released easily. So when you get to industry where you see a vertical separator, you know is that what is happening there, they are releasing gas for our crude oil there. So vertical separator only separates our gas and liquid, or you can say gas and liquid. It always separates. We always remove gas from our liquid. So also one thing that we should understand, so let's create a new page. One thing that we should understand is our re-entrainment. Vertical separator prevents the happening of the re-entrainment in the separation process. Let me spell the re-entrainment so that it will not confuse you. So re-entrainment. So that is re-entrainment. So you spell RE-ENTRAINMENT. So you see here that re-entrainment. What is this re-entrainment? Re-entrainment is when gas, remember that in our separator, the gas is being removed for our liquid. So which is the help of that is done by the help of our mist extractor. we'll explain that when we get to that. Our mist extractor. So the mist extractor help to remove any liquid from our trap for our gas. It helps to remove any liquid for our gas. So this re-entrainment now, after the liquid has been removed for the gas, so this entrainment is when the gas not trap the liquid again. It can be water. When the gas not trap the liquid again, that is not a good operation. It can cause a liquid carryover. So when the gas not trap the liquid again, that is called re-entrainment. So of course we know the meaning of re-entrainment now. And I said gas vertical separator help to prevent the happening of the re-entrainment. It helps to prevent the happening of re-entrainment. So like I said, so like I said, for example, we have, why did vertical separator help to prevent the happening of re-entrainment? Let me explain. For example, we have our gas here. And then of course we have our liquid and our oil here. So we said when this gas now trap the liquid, that is what we call re-entrainment. When the gas trap the liquid, that's what we call re-entrainment. So why did that happen? It's because of the high velocity of the gas. So it happened because of the high velocity of the gas. So why did the vertical separator prevent the happening of the re-entrainment? It's because the distance between the gas and the liquid is large. The distance is large, so it will take a longer time for it to trap the liquid. So that's the reason why it prevents the liquid for re-entrainment. That's the reason why it prevents the liquid for re-entrainment. So it's better for horizontal separator. It can easily be re-entrained. The gas can easily trap the liquid. So that is it. So let's come to our horizontal separator. So in this horizontal separator, we have our two-phase. We have horizontal separator. Let me draw it here. Let me create another slide. So for example, we have horizontal separator. So the question is that when you get to an oil and gas industry, when you see a horizontal separator, the question you should ask is that why do we use horizontal separator in this place? So today you will know the reason why. So horizontal separator, if the amount of liquid is too much, when you compare that with the vapor or gas, then it's better to use the horizontal separator. So horizontal separator is considered as oil or liquid separator. So when you have too much liquid on our crude oil, so it's better to use horizontal separator to separate it. Remember that vertical separator is when we have too much of gas on our crude oil and want to release the gas. So it's better to use vertical separator. And then when we have too much of liquid on our separator, it's better to use horizontal separator. So I will explain how this is possible, how this is done. For example, we have our gas. We have our gas here, and we have our crude oil, and we have our water at the bottom. So the water outlets will be at the bottom, and the gas outlets will be at the top. So the gas outlets will be at the top, the water outlets will be at the bottom. So we should take note of that. If we want to separate liquid from our separator, we should use horizontal separator. So when you get to an industry or oil and gas industry, when you see a horizontal separator, one thing that will come to your mind is that the most important thing that they are separating is our liquid. So our cool, it's our water, so our liquid. So one thing that will come to your mind that we does not have too much gas on that separator. So we are majorly separating our liquid or our water. So if you have too much water on our separator, it's better to use a horizontal separator. So another thing that will come to our mind is that a horizontal separator is good for foamy creams. You can call it foamy crude. Foamy crude. Foamy crude. Of course, I will write it so that you understand. Foamy crude. So it's better for foamy crude. So it's better for what is foamy crude? Foamy crude is when crude oil trap liquid. Remember that in our separator, the crude oil, this is the line of the crude oil, and then we have this is the place of the water. Remember, the crude oil line is called oil weir. So, and we have our water, and we have our water here at the bottom. So if this water now mix with this crude oil, it will cause a foam. Or we can say when this crude oil now trapped gas, it will cause a foam. It will be foam. The oil will be foam. So how this horizontal separator prevents this foaming is that you see that if there is a foam, it can easily spread around the separator. So that means it can easily collapse. The foam can easily collapse in the separator and it can be reduced. But if it is vertical separator, if there is a foam, and you can see here that it's vertical, we have gas, and then we have crude oil, and we have our water. So it will be difficult for it to collapse, for it to distribute. It will just settle down. It will settle down vertically. So it will be difficult for the foam to be reduced. But if it's sorry for that. So if it is a horizontal separator, it will easily the foam will easily distribute in the separator, and the foam will reduce. The foam will reduce. So that is horizontal separator. So that is the reason why we use horizontal separator. And the horizontal separator help to reduce it are not good. Horizontal separator are not good for solid handling. So horizontal separator, they are not good for solid handling. For example, if we have a solid particles on our crude oil, horizontal separator is not good to handle that. It's not good to handle that. So vertical separator is better to handle our solid because it will settle down straight. And it will easily be removed. And what we use to remove solid particles is called a water jet system. So it can easily settle down or the separator if it's vertical, and it will be removed by a water jet system. So that is the difference between vertical and the horizontal separator. So when you get to the industry where you see a vertical separator and a horizontal separator, you should know it's why are they using vertical separator here, and why are they using horizontal separator here. So again, one thing we should also know that horizontal separator, vertical separator, it does not actually take too much area. So vertical separator holds a smaller footprint. So you can see here that the horizontal separator take a large area. So that is another important reason. So you take a larger area. By vertical separator take a smaller space, or let's call it space, smaller space. So also vertical separator there's a poor accessibility to the vertical separator. So for example, if you want to climb to the top of the separator, you have to use ladder, or take it more effort for you to climb to the top of the separator. So remember that we have our protective equipment at the top of the separator. So if you want to, for example, go and see the PCV, which is the pressure control valve, I will explain that later. So you have to climb up. So you have a poor accessibility to the vertical separator. So that is the difference between vertical separator and horizontal separator.